Okay, so hello everyone, and thank you for joining me today. This is the second in a series of webinars where we are covering the different domains of the AWS Certified Developer Associate exam. As a quick introduction to myself, I'm Stuart Scott. I'm the AWS Content and Security Lead here at Cloud Academy, where I've created and published over 100 courses relating to AWS, and you'll find many of them that relate to this particular certification. Also, if you have any questions throughout the webinar, then please use the chat window to submit them, and we'll get to as many as we can when we go through our Q&A section towards the end. One other point to mention is that this webinar is being recorded, and so you'll receive a link to it within the next couple of days. So today's session is going to focus on Domain 2, centered around security. And this is broken down into 3 different subdomains that you'll be assessed upon within the exam. And these being 2.1, make authenticated calls to AWS services, 2.2, how to implement encryption using AWS services, and 2.3, implementing application authentication and authorization. And this domain equates to 26% of your total score, so it's definitely worth investing some time into this area. So bearing in mind the domain assessment points that I just mentioned, there are a number of key services that you should be familiar with, especially from a security perspective. So today I will be covering these services starting with Identity and Access Management, known as IAM. So I'll be talking about how you can implement cross-account access and the steps needed to implement it, the importance of multi-factor authentication to enhance security, and how it can also be used to authenticate specific API calls as well. I should also be looking at how to enable programmatic access for users, and finally, an overview of policies. I should then be looking at Amazon Cognito to provide an insight into the differences between user pools and identity pools and how these elements fit together to provide authentication for your mobile apps. Following this, I look at API Gateway. I'll review what the service is at a high level before looking at the different options to control access to your APIs and some API Gateway security best practices. I should then be looking at AWS Secrets Manager to explain what it is and what it's used for, followed by defining what a secret is and the different service integrations and policies used to protect your secrets. And then next up, we have Key Management Service, KMS. So I want to talk about how KMS can be used for encryption, highlighting the core components, including the customer master keys, data encryption keys, key policies, and also grants as well. And then this leads nicely into Amazon S3 encryption, which is covered in the exam. So I'll be spending a bit of time discussing the different S3 encryption mechanisms to ensure you are familiar with them. And then following S3, I will finish by looking at encryption for the Elastic Block Store service and some of the points to remember when working with encrypted volumes. And then after that, provided we have time, we'll just look at a couple of sample questions and how you can kind of go about answering them, and then we'll look at the Q&A. Okay, so there's a ton of stuff to get through, so let's get started. So when I took the exam, there was definitely a requirement to have an understanding of cross-account access with IAM. But what is it? Well, basically, it allows IAM users from one AWS account to access services within a different AWS account through the use of IAM roles, which allow you to adopt a set of temporary IAM permissions to access those AWS resources. So let's look at an example. Now, you might have a production account and a development account with users in the dev account. Now, your development team works primarily in the development account, but may occasionally require access to resources in the production account. Now, instead of creating additional user accounts in the production environment, which would only be required on rare occasions, roles could be used with the required permissions instead. Now, the dev team could then assume those roles to access the resources in production, and this helps to adhere to the principle of least privilege. Now, when working with cross-account access, you need to understand the difference between the trusted account and the trusting account. Now, using this example between production and dev accounts, the production account will be the trusting account and the development account would be the trusted account, as the development users will be trusted to access the resources in the production account, which is trusting those users. Now, there's four main steps to configure cross-account access. These being, firstly, you need to create a role within the trusting account. And as you can see in the bottom picture there, you must select the Another AWS Account option as the trusted entity. And this will establish a trust between the two accounts. You must then assign the correct permissions to this role. And then in the trusted account, you need to grant permissions to your users to be able to assume that role created in the trusting account. And then finally, just test the configuration by switching to the role. So let me talk more about roles, as they come up quite a bit in the exam. So it's essential that you have a good understanding of them. Now, roles are identities, much like users are, which have an associated set of permissions that allows them to access AWS resources. Now, a role can be assumed by other identities and resources, such as users in your own AWS account or by a user in a different AWS account, as I just explained, or by a federated user or another AWS service such as EC2. Now, when the role is assumed by one of these methods, the identity will inherit the associated permissions of the role. Now, also, roles themselves do not have static credentials. Instead, they are dynamically created when the role is assumed. Now, when creating a new role, you have four different options. So we can see the AWS service there, known as service roles, another AWS account, web identity, and SAML 2 federation. So service roles, these allow other AWS services to perform actions on your behalf. And as you work within AWS and begin to utilize and configure various different services, there will be requirements where the service will need to create service roles in order to perform specific steps and functions. For example, during the configuration of AWS Elastic Beanstalk, a service role will be created allowing Beanstalk to use other AWS services on your behalf. And this role will have all of the required permissions to allow the service to carry out the necessary tasks that it needs to. But remember, service roles only exist in the account in which they are created, and they can't be used for cross-account access. And when you create a service role for EC2 via the console, then there's two components that are actually created: the role itself and also an instance profile, and they both have the same name. The instance profile is essentially a container for your role, and it's used to pass data to the EC2 instance from the role itself. And now, if you use the EC2 console to create your instance and you select the drop-down list that you see showing all the roles to associate to the instance, then this list actually displays the list of instance profiles and not the role. However, they are the same name, so it just looks exactly the same. Next, we have the other option, which is another AWS account. So these are roles that can be assumed by a user either in the same or different AWS account. When a user assumes a role in their current account, then their current set of permissions associated with their user identity is temporarily replaced with the permissions associated with the role. Now, to assume a role, the identity also needs to have the relevant permissions to do so, and without these configured permissions, then access to the role is not possible. And the role can be assumed either through the management console or programmatically via the AWS command line interface, the CLI. Now, if the user switches to the role from within the management console, then the identity can do so for an hour. If the role was assumed programmatically using the assume role command at the CLI, then the role can be assumed for a minimum of 15 minutes or up to 1 hour by using the parameters duration seconds. Web identity. So this option allows users who have been granted federated access to your AWS resources through a web identity provider to assume these roles instead of via a user that has been created within IAM. So federated access simply means that the user has been authenticated by an external source. And in the case of web identity federation, this could be via well-known identity providers known as IDPs, such as Amazon, Google, Facebook, or even Amazon Cognito. I'm sure you've seen it on various websites where you'll be asked to log in and you can use one of these web identity providers as your authentication. Then we have SAML 2 federation. This option, which allows you to create roles, are ones that have been federated through your own internal corporate directory. So this differs from web identity in the fact that the external authentication system is your own corporate directory of users. For example, your own Microsoft Active Directory, and you can use LDAP, which is Lightweight Directory Access Protocol, to query your Microsoft Active Directory as your authentication into your AWS account. And this provides a single sign-on approach to your AWS environment. So what is MFA? Well, MFA uses a random 6-digit number that is only available for a very short period of time before the number changes again. And this is generated by an MFA device, a multi-factor authentication device. There's no additional charge for this level of authentication. However, you will need your own MFA device. And this can either be a physical token or a virtual device. Now, myself personally, I use a virtual device. It's just an app called Google Authenticator. It's very easy and simple to install and configure. When you're setting it up, it's configured and associated to individual users within IAM. And as you can see on the image on screen, on the right-hand side, when configuring it for a user, you must enter the number that appears on the MFA device as authentication code 1, and then wait until the number changes on the MFA device, and then enter that second number as authentication code 2. And this will synchronize and associate the MFA device with that user. Now, you can also ensure that a user is authenticated with MFA to make specific API calls. For example, as you can see on the bottom left there, I have a policy. Let's suppose you had a user called Bob, whereby you wanted to force Bob that he was authenticated via MFA to perform the terminate instances API call. Now, to do this, you would have to have the policy shown on the screen associated with Bob's permissions. And you can see at the bottom where it says condition, it states that the MFA must be true to perform that action. So if he wants to terminate instances on EC2, then he must be authenticated with multi-factor authentication to carry out that API. Sometimes your users will need programmatic access to your AWS environment instead of just using the management console. And as you can see on the image, when creating a new user, you can set these options under access type towards the bottom. For programmatic access, an access key ID and secret access key will be issued to be used with the AWS CLI, SDKs, or other development tools. And these access keys are required for the programmatic access for authentication. The access key ID is made up of 20 random uppercase alphanumeric characters, and the secret access key is made up of 40 random upper and lowercase alphanumeric and non-alphanumeric characters. Now, during the creation of a user who requires programmatic access, you are prompted to download and save these details, as the secret access key will only be displayed once. And if you lose it, you will then have to delete the associated access key with the user and then recreate new keys for that user. And then to configure the AWS CLI using these access keys, you simply just need to run AWS configure from the command prompt. Having an understanding of Iim policies is crucial. I would say not just for the developer associate certification, but pretty much for all of them. And there are 3 things you should definitely focus on. Firstly, you need to understand the difference between identity-based and resource-based policies, the general structure and parameters of an Iim policy, and how policy evaluation logic work. So let's take a look at them. Let's take a look at the first one. So identity-based policies. If you've been using AWS for any length of time, then this type of policy is probably the most familiar to you. You're able to attach these policies to identities that have been created within IAM, such as users, groups, and roles, and they are essentially associate specific permissions to a particular identity. Identity-based policies can either be AWS managed, customer managed, or inline policies. So let's take a look at each of those. So the AWS Managed Policies are predefined policies that can be found within IAM, and they are available to use without having to create your own policies. So they're just a list of predefined policies that you can just select. The customer managed policies are policies that have been customized by us as customers, and they give you far more granular control over how you want to manage access for identities than those of AWS managed policies. Because when you look at the AWS managed policies, they might not fit exactly what you need for your specific needs. So you just need to create your own ones. Then you have inline policies, which are different to both AWS and customer managed policies. In that, inline policies are embedded directly into the identity object, for example, a user, whereas managed policies are stored within IAM as separate objects and can then be assigned to multiple identities, for example, groups, roles, and users. Inline policies are not stored as separate objects. They only exist within the identity of which they are created within, such as a user or role. But as a general rule, it's best practice to use managed policies over inline policies where possible. Then we have resource-based policies. And these are essentially, I guess you could say, they're like inline policies, but instead of being attached to an identity object, they are instead attached to resources themselves. For example, one of the most frequently used resource-based policies is that of Amazon S3 bucket policies. Now, because these policies are not attached to an identity, there needs to be a parameter within the policy that defines a principal. So AWS knows who or what these permissions apply to. And this principal relates to an identity and can either reside within the same AWS account or, in fact, a different account. So let's now take a quick look at Iim Policy Structure. And this is something worth dedicated time to as well, because you must be able to confidently review and interpret these policies. And it's an essential skill through all of the AWS certs. So firstly, all Iim policies are in JavaScript object notation, which is JSON format. And you can see on the screen a very simple policy on the left-hand side there. It's an identity-based policy, and we know it's an identity-based policy as there isn't a principal element, which would indicate it was a resource-based policy. Anyway, we have a number of different parameters, so let's run through them quickly here. So firstly, we have the version, and this simply shows the version of the policy language being used by AWS. The statement, this acts as a group for the following parameters, and each policy that you create can have different statements within them. Then we have the SID. This is simply a statement identification, the value of which can be anything to make logical sense of the statement itself. In this example, I've simply added the value of sample policy, allowing me to quickly identify what I'm using the policy for. The effect, this can either be a value of allow or deny, and this simply allows or denies access to the resources within the statement using the actions listed. It's pretty straightforward, that one. Action. Here you are able to list a number of different actions that you want to either allow or deny access to, depending on the value of the previous parameter, the effect parameter. And in the example, I've listed two actions. You have S3 put object and S3 get object. The action is first defined by its service, such as S3, then followed by a colon, which precedes the action itself within the service. Next, we have resource. This provides the ARN, which is the Amazon resource name, as to which resource that these permissions apply to. So in the example, it points to all resources within a specific bucket. Condition. The condition element is actually an optional parameter. You don't need to have it. But it allows you to dictate under what conditions or circumstances that the policy comes into effect. And in my example policy, I have a single condition, which contains condition operators that specify the values of that condition. So this condition is based on the IP address of the identity that it applies to. And for this condition to be met, the source IP address of the identity trying to access the bucket resource using either an S3 put object or S3 get object must be in the network range of 10.0.0.0/16. And if you've not worked with conditions before, it's also possible to have multiple conditions within the statement, which are known as condition blocks. And in a condition block, the conditions are evaluated together using a logical AND, meaning all conditions in the block must be met before the permissions are put into effect. Now, the policy structure for resource-based policies is essentially the same as the identity-based. However, there is one significant difference, and that is the principal parameter. Now, the principal is used within the resource-based policies to identify the user, role, account, or federated user that the permissions should be applied to either allow or deny the access, and is defined by the ARN of the principal. Now, this is the last slide on IAM, thankfully, but I want to quickly explain at a high level how policies are evaluated when a user belongs to more than one. So firstly, AWS will determine the principal of the request through authentication. Next, AWS will define which policies should be used based on the access request. For example, if access to an S3 bucket was requested, then are there any bucket policies in place that need to be reviewed? Following this step, AWS will review the different policy types in a specific set order. And then finally, as long as an allow exists in any one of the policies associated with the request access, then the access will be allowed for the relevant action. However, if a deny exists in any one of these policies that applies to the same resource and action as the allow, then access will be denied. So just remember that a deny always takes precedence over any allow. Okay, let's move on from IAM. So let's go onto something different. Let's take a look at Amazon Cognito. Now, this service might not be as familiar to you as IAM, but I encourage you to take a look at it, understand it, see what it is and what its components are. Amazon Cognito has been built purely to enable the simplification of enabling secure authentication and access control for new and existing users accessing your web or mobile applications. Now, it not only integrates well with Enterprise Federation, but also with Web Identity Federation as well. And one of the biggest features of Amazon Cognito is that it has the capability to scale to millions of new users, which is great when working with mobile applications, especially if you've got the next app that's taken the world by storm. So there are two main components of Amazon Cognito that you should be aware of, these being user pools and identity pools, and they perform different actions. So firstly, user pools. Now, user pools are essentially a scalable user directory that allows new users to sign up or existing users to log into your mobile application using their native credentials from the Cognito user pool. Or they can alternatively federate that access via a web or enterprise identity provider, an IDP. Either way, a profile within the user pool is created for each and every user. And these profiles don't actually contain permissions of access to your AWS infrastructure. They purely allow them to log into your mobile app as an authenticated user. Now, when logging in, Cognito can be configured to present a personalized sign-in page with branding and your own logo, etc. And once a user is authenticated via the user pool, either from the user pool itself or via a third-party identity provider, Amazon Cognito will generate tokens which authenticate the access to your mobile application. Now, it is also possible to enable additional features using the user pools, such as the ability to enable multi-factor authentication, MFA, which provides additional security to your user base. And you can also create user pool groups and assign different permissions to different groups as well. And this provides a greater control of access and prevents all users from having the same level of access, which might be a bit of a security risk. And then we have identity pools. Now, identity pools are different to user pools in that these actually provide you with the ability of assigning permissions to users to access your AWS resources used within the mobile app by using temporary credentials and the security token service. Now, identity pools support federated access for users that have been authenticated by user pools, OpenID Connect identity provider, Saml, and social identity providers as well, and developer authenticated identities too. Now, these permissions are assigned through IAM roles and can be mapped to different users to provide different permission sets. Now, once a user has been authenticated either via a user pool or from a federated IDP, the token received and managed by Amazon Cognito can then be exchanged in the identity pool for temporary credentials using the security token service. And these credentials can then be used to access your AWS services when using your mobile app. Now, these two pools, both the user and identity pool, can be used together or separately, depending on the function requirements of your mobile application. Now, when it comes to monitoring and auditing of requests to your pools, you can use both Amazon CloudWatch with its range of metrics specifically tailored to Cognito, or CloudTrail to maintain a list of auditable API calls made from the Cognito service. Now let's take a high-level look at how Amazon Cognito works with the different pools and tokens that I mentioned. So let's start with our mobile application in which we want people to use and authenticate to. So this first step is to manage the authentication, and we can use our Cognito user pool to do this. Now, when a user is presented with our sign-in page, they can either use their native Cognito user credentials they created within the user pool, or federate their access using a web identity provider such as Amazon, Facebook, Google, etc. Now, at this stage, an identity token is sent by the IDP back to the Cognito user pool. And now Cognito doesn't actually store the credentials sent by the IDP or forward this to your mobile app. Instead, the IDP token will be normalized into a standard token called a Cognito user pool token, or CUP token. And this will be used and stored by Cognito. This essentially means that it doesn't matter if the user authenticated via an account in the user pool or if that was authenticated by federated access. All tokens are standardized and sent back to your app. And this will verify the authentication of access to the mobile application. Now, the actions carried out by the user on your app might also need access to back-end serverless services for APIs that you have created. So you might be using API Gateway or Lambda, which accept CUP tokens. So Cognito will use the same CUP token to authenticate and authorize you to use those APIs with API Gateway, etc. Now, some services do not allow you to use CUP tokens for authentication. And if your mobile app requires access to services such as Amazon S3 or DynamoDB on the user's behalf, then you'll need to use the identity pool to authenticate. So the CUP token can be sent to the identity pool, and this is where an STS token, security token service token, will be created based off of your CUP token, and this will be sent back to your application, which contains standard AWS credentials that will allow you to call upon those other AWS services using AWS APIs. So I know that was a fair bit to take in there, so you might want to watch back on this when you get a copy of the webinar, just to make sure you kind of understand the process flow there. Okay, next on the list we have the API Gateway. Now, this is another fully managed service offered by AWS, again, making life easier for developers by simplifying the creation, management, publishing, monitoring, maintenance, and security of APIs at scale. And this allows for efficient API development, enabling you to run different versions of the APIs at the same time, giving your developers opportunities to modify and test and publish new and updated versions of those APIs. You can use it to build RESTful APIs for your serverless workloads or backend HTTP APIs. It also supports WebSocket APIs, which allow you to create a two-way communication apps and real-time streaming dashboards. Amazon API Gateway provides central access for various functionalities, such as exposing backend services, data access, Lambda functions, containers, or web applications running inside or outside of AWS. And it generally unifies API handling across different applications or code bases. So there's no need to worry about building and logging and caching authentication or other kinds of expansion points that you had to deal with in a traditional API management solution. Also, API Gateway uses the same authentication signature as other AWS services. So this means we can leverage IAM to manage access to your APIs in addition to Amazon Cognito, which we just looked at. And you can also create and distribute API keys for third-party developers too. And API Gateway may be integrated with CloudFront for easy caching and global CDN. And the API Gateway also provides a centralized place to manage all of your APIs with CloudWatch. And this telemetry data is generally enough to gauge the performance and assess its operational state. So let's take a look at some of the ways you can control access to your APIs created with API Gateway. So firstly, resource policies. Using policies associating with your APIs, you can restrict access based on user, source IP address, or even VPC endpoints. Using IAM roles and policies. So in addition to resource-based policies, you can set identity-based policies to also restrict or grant access to an API, allowing you to clearly define who can create or even invoke them. Endpoint policies for interface VPC endpoints. Again, using resource policies, you can enhance security of your private APIs by attaching policies to the interface VPC endpoints, known as VPC endpoint policies. Lambda Authorizers. Now, this is an API gateway feature that enables you to use a Lambda function to control access to your API using a bearer token authentication strategy, such as Saml, which is a token authorizer, or that uses request parameters to determine the caller's identity, known as a request authorizer. We also have Amazon Cognito user pools, which we looked at a moment ago, and this allows you to use the user pools for authentication and authorization for your REST APIs. And then we have client-side SSL certificates. Now, these can be used to ensure that any HTTP requests to your backend system are from API Gateway. Let me now highlight some of the best practices from a security standpoint when working with API Gateway. Firstly, implement least privilege principle. And this should really be applied across the board and not just for API Gateway. You should only ever grant the permissions required to carry out the work necessary. You should restrict as much as you can using a variety of different policies where you can. Implement logging. Make sure you use services such as CloudWatch with CloudWatch logs, or even Kinesis Firehose to log requests to your APIs. Implement Amazon CloudWatch alarms. So Amazon CloudWatch alarms, they tightly integrate with metrics that can be used for API gateways, such as the cache hit count. And they will allow you to implement automatic actions based on specific thresholds that you can set. And this will allow you to respond to those thresholds if there's any issues. Enable AWS Cloudtrail. Again, I recommend enabling CloudTrail anyway within your account, not just if you're using API Gateway, just to help you audit any actions taken by a user, role, or AWS service, such as API Gateway itself. And enable AWS Config. AWS Config allows you to utilize config rules to help you manage and maintain configuration, acting as an automatic resource compliant checker as such. When a change is made to a resource, AWS Config will check to see if the resource matches the rule with the help of a Lambda function. And so it will check the compliance of that resource against that rule following the changes made. And this can be used to spot any non-compliant settings of your API gateway resources, allowing you to take necessary actions. Okay, moving on to AWS Secrets Manager. So what is it? It allows the ability to maintain a level of security protection for API keys in addition to other secrets. Now, you might be wondering, what is actually considered a secret. Within Secrets Manager, a secret is something that you want to remain hidden and protected instead of being available as open access to anyone to read it. So this can include database credentials across Amazon Redshift clusters and Amazon RDS, instance passwords, plain text, or like I mentioned earlier, API keys. An AWS Secret Manager holds, protects, and contains this sensitive information for you, allowing other services and applications to call for the secret via a simple API call. And this negates the need for your application developers to hard code any secret or credentials within your applications. Instead, when a secret value is required, an API call to AWS Secrets Manager is triggered instead, which will then return the value. And this method is far more secure than hard coding secrets. Also, Secrets Manager can automatically manage the rotation of secrets, meaning you don't have to manually do this yourself. And it might be no surprise that the AWS Key Management Service, KMS, is tightly integrated into AWS Secrets Manager to help encrypt your secret values being stored. It's important that any secrets stored are encrypted. I mean, after all, they are of significant importance and must be protected as much as possible. It's also important to be able to audit the secrets as to who, what, and when they are being accessed. And thankfully, again, AWS Cloudtrail is integrated to maintain a log of when each secret is requested to ensure that you have a full audit trail of that secret and it can be recalled upon at any time. Resource-based policies are attached directly to the secrets themselves and defines which principals can perform which actions against that secret. And again, this can be done using the management console or the AWS CLI. If you look at that command at the bottom there, that following command would add a resource policy saved as resource.json to an existing secret named my RDS secret. So that could be run at the AWS CLI to apply that resource-based policy to that secret. Okay, we now move on to KMS, which focuses on encryption. Basically, the key management service is used to store and generate encryption keys that can be used by other AWS services and applications to encrypt your data at rest. So it's not used for in-transit encryption. So it's a fundamental security service offered by AWS to help you manage your cryptographic operations. Now, there are different types of keys used within KMS which perform different roles and functions. Some people think AWS have full control of our keys, but actually that they don't. It's down to us as a customer to ensure we secure them through the appropriate key policies. We must control who has access to them and the cryptographic operations that can be performed with them. KMS also integrates with a wide scope of other AWS services, as I've kind of already mentioned, to provide that at-rest encryption to protect your data. Importantly though, KMS is not a multi-region service like IAM is, for example. It's region specific, so if you create one key in one region, you can't use that same key in a different region. Okay, so let's now take a look at some of the components and features that make up the KMS service, and it's primarily based around 4 different elements. These being the customer master keys, the data encryption keys, key policies, and grants. So the customer master key, this is the main key type within KMS, and it contains the key material that is used to encrypt your data. And there are 3 different types of CMK, customer master key. We have the customer managed, AWS managed, and AWS owned. Next, we have the data encryption keys. Now, data keys are created by CMKs. However, they are used outside of KMS to perform encryption against your data, either in your own applications or by other AWS services. So when a request to generate a data key is received by KMS, the associated CMK in the request will create 2 identical data encryption keys. One will be a plain text key and the other will be an encrypted key. And during this encryption process, it's the plain text data key that will be used to perform the encryption of your data using an encryption algorithm. Then once the encryption has taken place, this plain text data key will then be deleted and the encrypted data key will be stored and associated with the newly encrypted data. And I'll show you an example of how CMKs and DEKs work in collaboration with each other when we cover S3 encryption in an upcoming slide. So key policies determine who can do what with a key. For example, defining who can use the key to perform cryptographic operations, in addition to those who can administer the CMK to perform functions such as deleting and revoking the key. Now, controlling access to CMKs can't be done using IAM alone. In all cases, to manage access to your CMKs, you must use a key policy. So there are a number of different ways in which you can control access to the CMK, these being via key policies alone, via key policies and IAM, and via key policies and KMS grants. So finally, we have grants, like I just mentioned, and these allow you to delegate your permissions between two people, but they can only be created programmatically. So you can use the AWS CLI, but not the management console. Now, when I sat the exam, I experienced questions relating to S3 encryption. So I just wanted to highlight it here. It's definitely worth investigating some time into understanding the differences between the options available. Now, depending on your requirements, one method of encryption may be more appropriate than another. So here's a quick overview of each. So firstly, server-side encryption with S3 managed keys, known as Sscc S3. This option requires minimal configuration, and all management of encryption keys used are managed by AWS. All you need to do is to upload your data, and S3 will handle all other aspects. Next, we have server-side encryption with KMS managed keys, known as Sse Kms. And this method allows S3 to use the key management service to generate your data encryption keys, and then KMS gives you a far greater flexibility on how your keys are managed. For example, you're able to disable, rotate, and apply access controls to the CMK, and also audit against their usage using AWS Cloudtrail. Next, we have server-side encryption with customer-provided keys, Sscc. And this option gives you the opportunity to provide your own master key that you may already be using outside of AWS. Your customer provided key would then be sent with your data to S3, where S3 would then perform the encryption for you. Then we have client-side encryption with KMS, Sse Kms. Now, similarly to Sse Kms, this also uses the key management service to generate your data encryption keys. However, this time, KMS is called upon via the client and not S3. And the encryption then takes place client side, and the encrypted data is then sent to S3 to be stored. And then finally, we have client-side encryption with customer-provided keys, Sscc. Using this mechanism, you are able to utilize your own provided keys and use an AWS SDK client to encrypt your data before sending it to S3 for storage. Now, to demonstrate an example of how KMS and S3 integrate, let me take a quick walkthrough at how the encryption and decryption process works for Amazon S3 server-side encryption with KMS managed keys, known as Sse Kms. Now, this infographic, I have the same for all of the other S3 encryption mechanisms, and there's a link to it at the bottom of the screen there. So if you go to that, it will show you an infographic I created for each of those 5 different mechanisms. So it might be useful just to take a look at that. So let's have a look, take a walkthrough through this. Firstly, let's start with encryption, and we can see we have 5 steps to follow. So step 1. Firstly, the client uploads an object to S3, indicating Sse Kms as the encryption mechanism with a specified CMK. Step 2, S3 will respond by initiating a request to generate data encryption keys from KMS. At step 3, KMS will then generate 2 data keys using the requested CMK, a plain text data key and an encrypted version of that same data key. Step 4, KMS will send both of these data keys back to S3. Step 5, S3 then encrypts the object data with a plain text version of the data key and stores the resulting encrypted object alongside the encrypted data key. And then the plain text data key is then deleted from memory. So when decrypting the same object, the following process is followed. So this is the section at the bottom of the screen. So firstly, a request is received by S3 to access an encrypted object via a client. Step 2, S3 sends the encrypted data key associated with the object to KMS. Step 3, KMS takes the encrypted data key and uses the original CMK to decrypt the data key to generate a plain text version of that data key. Step 4, KMS sends the plain text data key back to S3. Step 5, using the plain text data key, the encrypted object data can then be decrypted, returning a plain text version of the object data, and the plain text data key is then deleted from memory. And then the plain text object is sent back to the requesting client. So the final service I want to talk about is the Elastic Block Store, but specifically the encryption element of the service. So one of the great features of EBS is its ability to enhance the security of your data, both at rest and when in transit through data encryption. And this is especially useful when you have sensitive data, including personally identifiable information, stored on your EBS volume. And EBS offers a very simple encryption mechanism, simple in the fact that you don't have to worry about managing the data keys yourselves to perform the encryption. It's all managed and implemented by EBS. All you are required to do is to select if you want the volume encrypted or not during its creation via a checkbox. Now, the encryption process itself uses AES 256 encryption algorithm and provides its encryption through the KMS service, which we talked about earlier. Now, as we know, KMS uses CMKs to create data encryption keys, enabling the encryption of data across a range of AWS services, such as EBS in this instance. And you can either select an AWS managed CMK or a customer managed CMK. Now, when using encryption with EBS, all data stored on the volume is encrypted in addition to the data being sent between your EC2 instance and the volume itself. And any snapshot taken from an encrypted volume will also be encrypted, and also any volume created from this encrypted snapshot will also be encrypted. So you should be aware, one point to make on this is that encryption option is only available on selected instance types, so you can't have it on all instances. Another feature is that you can enable encryption by default to automatically enable encryption on all EBS volumes created within a specific region. It only works on a per region basis and will only encrypt volumes that are configured for encryption from the point that this setting is enabled. Okay, so that was quite a lot of information to take in, and also at quite a pace. I know you might not be able to kind of consume all of that, so I just wanted to highlight some of the areas that you should definitely have familiarity with, just to allow you to kind of look into it in some more depth if you need to. So let's take a break from that and look at a couple of example questions. So the first question, a company is migrating a legacy application to Amazon EC2. The application uses a username and password stored in the source code to connect to a MySQL database. The database will be migrated to an Amazon RDS for MySQL DB instance. And as a part of the migration, the company wants to implement a secure way to store and automatically rotate the database credentials. Which approach meets these requirements? So the key part to look out for is the fact that we need to implement a secure way to store and automatically rotate the database credentials. That's the key point in that question. So let's read through the available answers. So A, store the database credentials in environment variables in an Amazon machine image, an AMI, and rotate the credentials by replacing the AMI. Now, looking at that, we don't really want to be hard coding and baking any credentials into an AMI. It doesn't follow security best practice and doesn't offer an easy way of rotation. So I'd say no to that. So B, store the database credentials in AWS Systems Manager parameter store and configure parameter store to automatically rotate the credentials. Now, although AWS Systems Parameter Store can be used to store configurational data or parameter values and even secrets, it can't be used to perform automatic rotation of your secrets. So this is out too, as one of the requirements in the question is to automatically perform that rotation. C, store the database credentials in environment variables on the EC2 instances and rotate the credentials by relaunching the EC2 instances. Again, we don't really want to be storing anything on the instances themselves, and it doesn't really offer an easy and automatic way of rotation of our secrets. So again, this is out too. So D, store the database credentials in AWS Secrets Manager and configure Secrets Manager to automatically rotate the credentials. So as we know, we spoke about this earlier, AWS Secrets Manager allows you to both implement a secure way to manage secrets and also perform rotation of those secrets. So D is the correct answer to this question. Let's look at another one. A company has AWS workloads in multiple geographic locations. A developer has created an Amazon Aurora database in the US West 1 region. The database is encrypted using a customer managed AWS KMS key. Now the developer wants to create the same encrypted database in the US East 1 region. Which approach should the developer take to accomplish this task? Now the first thing to remember here is that KMS is region specific. So a key in one region can't be used in another. So let's look at our options. A, create a snapshot of the database in the US West 1 region, copy that snapshot to the US East 1 region, and specify a KMS key in the US East 1 region, and restore the database from the copied snapshot. So a snapshot of the encrypted database will create an encrypted snapshot. So far, so good. The snapshot can be copied across regions, and then you could specify a new KMS key in that region when restoring. So this could work. So let's keep that in our minds. B, create an unencrypted snapshot of the database in the US West 1 region, copy the snapshot to the US East 1 region, and then restore the database from the copied snapshot and enable encryption using the KMS key from the US East 1 region. Now, straight away, you can't create an unencrypted snapshot of an encrypted database. If a database is encrypted, then so will any snapshot be. So this is wrong and can be disregarded. C, disable encryption on the database. Create a snapshot of the database in the US West 1 region, copy the snapshot to the US East 1 region, and then restore the database from the copied snapshot. Now, again, you can't disable encryption on a database once it has been enabled. So again, straight away, we can disregard this option too. And then D, in the US East 1 region, choose to restore the latest automated backup of the database from US West 1 region and enable encryption using the KMS key in the US East 1 region. Now, you can't restore from automated backups across regions. You need to create a snapshot first and then copy it to another region to restore from. So again, this answer is wrong. So that means the correct answer here is A, which is kind of what we initially thought when we first looked at this. But it's always good when going through your questions to make sure you read all the questions before selecting your answer. Even if you think that is the right answer and you're fairly confident, just have a read through of the others, because sometimes they can change one word in the answer that you might have missed, and it will give you the wrong answer. Okay, so let's see if we can squeeze in a couple of questions just before we finish. I know we've only got a couple of minutes left, but let's see if we can get through a couple of questions. So let's just bear me a moment. I'll just take a look to see what's come in. Okay, so is there an easy way to remember all the different types of storage offered by AWS for the exam? I guess there is no easy way to remember, but if you try to associate each storage service with a type, it can help you remember what they do. For example, S3 is used for object storage, the Elastic File System is used for file level storage, and EBS is used for block level storage. But we have a course here at Cloud Academy called AWS Storage Fundamentals for AWS, and it covers the AWS storage services and gives a clear definition between them. So that might be worth taking a look at. Next one, how can I handle the networking and security section of the certification? A great way is to get some hands-on experience, learn the theory of the topics, and then I would say just get your hands dirty by playing around with the service. I mentioned a number of the security services today, such as Iim and KMS. So check them out either in your own AWS account, if you've got your own AWS account, or better still, use our hands-on labs, which can help you and guide you through the service. But it's just a case of getting to know the service, getting hands-on, launch some things, configure some resources, and just get to know it. It's kind of the best way, but I would definitely suggest doing the theory first and then start playing with the service. What will the exam look like? Which environment, and do we need a camera or microphone on? So if you are taking your certification from home, which I imagine most people will be at the moment, then yes, you will need your mic and camera on for sure. You need to be able to show the assessor around your environment with your webcam to ensure there isn't anything in view that can help you during the exam. So any papers or notes and headphones need to be put away. The area needs to be clear and tidy. Your microphone should be on, as they need to hear if anyone else is in the vicinity. And if they do hear someone, they do have the right to stop the exam and foul you, and you'll have to retake at a later date. So be sure to be somewhere that is private and quiet if you can before sitting your exam. Is the course material provided by Cloud Academy sufficient for this exam, or do you also recommend some external reading? So we have built a learning path here at Cloud Academy to cover this certification. It covers all elements of the exams across all domains with courses, hands-on labs and assessments. So it does cover everything, but if you do want to do additional studying, I'd never say no to people for doing extra reading. So by all means, you can go ahead, but our learning paths do cover everything you need to know for the exam. Let's have a look at the questions here. Someone's asking if KMS can be used for data encryption in transit. No, KMS is only used for at-rest encryption. So yeah, it's only used for at-rest encryption. It can't be used for in transit. Someone's asking, is it better to take the Cloud Practitioner certification first before the developer one? If you are new to AWS and you don't really have much experience with it, I'd say less than 6 months experience of AWS, and this is maybe if you're going for your first certification, then the Practitioner might be a good first step, just to help you into the world of AWS and understand some of the core components at that more basic level. It's the Practitioner isn't a super technical exam, so it is set at a slightly lower bar than the associate levels. So if it is your first AWS certification and you just want to build some of your confidence, then perhaps go for the Practitioner first. But I know many people who have gone for the associate levels first, where they have invested time studying and given themselves plenty of hands-on experience. Okay, so I think we're almost running out of time. So before I go, I just want to, well, we pretty much covered this anyway with the questions you submitted, but I just want to highlight the learning path that I did just mention that we have here at Cloud Academy. It's the Certified Developer Associate preparation for AWS. It covers all domains of the AWS Certified Developer Associate. It's got 31 courses, 24 hands-on labs, assessments peppered throughout, and a preparation exam at the end. So it has everything you need to ensure you pass successfully. So please do come and take a look. And finally, thank you. Thank you all for listening and joining me today. I hope it's provided some insight into the security elements that you need to focus on for the Developer Associate certification. If you have any more questions, then please feel free to reach out to me directly using the details on the screen, and I'll get back to you with an answer. You can also find more information on many of the services mentioned today within our library here at cloudacademy.com. So please do take a look. That's it for me. So thank you and goodbye.